Okay, so we're going to solve this problem here. And we've got an initial volume of 10.25 milliliters hydrogen sulfide gas in the freezer with a temperature of negative 6.2 degrees C, which we're going to have to change to Kelvin. We take it out in the sun, the volume swells, so that's volume 2 is 12.77 milliliters. And the question is, what is the temperature outside? Okay, so we don't know what it's going to be. We're going to figure it out. All right. So first, let's change our temperature to Kelvin temperature. So we've got negative 6.2 degrees C, and we're going to add 273.15 to that to get our Kelvin temperature. Okay. Now, there's a couple ways to do this, by the way. You can actually add a negative 6.2, or you can subtract 6.2. If that doesn't confuse you, I hope it doesn't by saying that. That's 266.95. We've got an empty slot right here. That 5 has to be rounded off. This 9 then rounds up to a 10, and the 1 then is stuck on over here and added to this 6. So we're going to get 267, and we have to have that 0 there because that's part of the precision of the answer. So there's the temperature we actually want, 267.0 K. All right. So we have a list of knowns and unknowns that fits some equation. If we look on our list of equations over here, we can see we got a V1 over T1 equals V2 over T2, and we have V's and T's in this list. So that's all we have is V's and T's. So that's the best equation to use. V1 over T1 equals V2 over T2. Now, the reason I had you stop here is we can do something right now to make this easier to solve. Or you can plug in your unknowns and then do the thing that's required to make it solve. It doesn't matter. Any way you go about it, we've got to have the unknown on the top of a fraction. One thing I said earlier when we're talking about, there were 3 things I told you kind of need to remember when you're solving these problems. One of them is you cannot solve for a variable that's on the bottom of a fraction directly. Now you can solve for it with a lot of manipulation, but you can't do it directly. So we don't want to try and solve for this. We want to try to arrange it so our variable is on the top of a fraction. Okay, so this is what we're looking for. This is what we want to have. Well, we can get T2 on the top if we do the same thing to both sides, and the same thing we want to do is just flip both sides. Just flip it upside down. Okay, so we can rewrite the equation as T1 over V1 equals T2 over V2. The reciprocal, right? Okay, and as long as you do the same thing to both sides, that's allowed. So now we can plug in our knowns and unknowns, and we'll be solving for a variable that's on the top of a fraction. Okay? So let's start plugging them in now. You can do that. This is the same thing you did previously. Say again? That's T1. You've got to have your temperature in Kelvin. That's why we have using that instead of negative 6.20, negative 6.2 degrees C. And then T2 we don't know. It stays just T2. V2 is 12.77 milliliters. All right? And then we want to multiply something on both sides that will get that T2 by itself. We're trying to isolate the unknown. And what we can do to this side that gets T2 by itself is multiply this side by 12.77 milliliters, which I have to do to both sides because, again, what you do one side, you have to do the other. 12.77 milliliters over 1. Now I can cancel all of this because it's exactly the same on the top and bottom, and we have T2 by itself on the top of a fraction. Over here we can cancel milliliters because that's the same on top and bottom, and we're ready to plug in and find the answer. So what we want to do here then is to take 12.77 and multiply it by 267.0, hit enter or equals, and then as a separate operation then take that number and divide. If you hit your divide button, it'll say something like answer divided by, or it might not say anything, but it's doing the division. Most calculators do it that way. Divided by 10.25, hit enter, and I get 332 and a long number. Okay, and I'm going to put a whole number down here. 332.6429.29268. Units of measurement I have left is Kelvin. That equals T2. What?
I might be working a little ahead of you, but
well, let's wait then. If you think you're working ahead of me, just hold that thought for a second, okay? All right, so I've got how many significant digits up here in the problem?
Which one got
Four.
4 of them. What?
all of them got 4.
Yeah, they are.
All of them have 4. So we need our final answer to be in 4. 1, 2, 3, 4. So this is the first insignificant digit. Now underline everything from there over and round it off. And we get 332.6K equals T2. Now the answer says what's the temperature? Well, that is the temperature. So that's all you have to do. However, if you want it in Celsius, which is easier to work with, then we have to subtract 273.15. You want to do that?
No.
Well, you don't have to, but I will do it for those who do. How about that? Okay? So we got, let's see, 332.6. Might as well practice now. You might need it later. K. Because you have to. You cannot solve the gas law problem itself unless the temperature's in Kelvin.
So what's the final answer got to be here?
No.
But you
What
know,
the final answer got to be in?
This is the final answer.
So what does it have to do?
That's fine. It's a temperature. The question only asks for the temperature. Doesn't say what temperature units.
So why you switch?
so if it's say a temperature unit, you got to make sure it's that temperature unit.
You have to give me the temperature in the degrees or units of measurement it's asking for. And if I don't ask for a specific one, you can give it to me in any units you want to. Okay? All right, but if we wanted degrees C, if we want to do it in Celsius, then I would subtract 273.15 from that answer. All right? So we want to do 332.6 minus 273.15, 59.45. But we've got this empty slot right here. So then we round it off to 59.5 degrees C. So either one of those answers, the way that the question is worded, what is the temperature? Since it does not specify what temperature units to use, either one of these answers is the correct answer. Both of these measure the same thing. Okay? Any questions about that?